gRPC server. Let's say that I implemented this one by using Golang on my server side. And on the client side, there is a gRPC stub. So what is this? Actually, in the gRPC server side and client side, we are using a common shared stub, which is derived from the protocol buffers and the gRPC messages. So we have a protocol buffer definitions. We generate both server-side implementation structure and then client-side implementation structure. If you have a proto definition, you can generate stuff for Java, C++. That means within your Java language, within your Java program, you can just contact to your gRPC stub. So it is something like you are executing your function locally, but actually it is processed on the server side. You send proto request and you may get proto response for this kind of sections. If you have proto definitions, you can generate all the stuff for all kind of languages. You need to check gRPC website, what is the supported languages on this part. We are talking about message interchange, but it is all handled by protocol buffers. And protocol buffers is an open source mechanism for serializing structured data provided by Google again. So you have a structured data on the client side, while you are sending this one to server side, you are just serializing it, right? So it is automatically handled by the protocol buffers. And you basically define your data structure in the proto file. And this data is structured as a message. So we will see in the example, there will be a message definitions. Of course, when you define your data structure in the proto file, you need to compile them to generate their stubs. And protocol buffer compiler, which is called proto, you can generate the data access classes and within the preferred languages. So you can say that, okay, proto C, just generate the stub classes, the required libraries for me for Java. And this time just generate them for C++. So you can do that. And they are all fine within the, how can I say that? You can include this one within your CI pipeline. So whenever you update your proto messages, you can generate the desired data access classes based on your needs. Also, there is messages, but what about services? Because messages are not meaningful without any kind of service, API, the service interface, right? And you can also define your services in the proto file. So in proto file, most probably you will see messages and the services. This is a sample message that you can define in your proto file. You see, this is a login request. Think about you just implemented the REST API. And within this REST API, there is a login endpoint, and this is the login request for your login endpoint. And this login request contains two fields, username and password. So let's analyze this part. Here, first of all, you define your scalar type. Let's say that the data type for this variable field, which is called scalar types. And scalar types, including various data types like double, integer, string, etc. You can just search for protocol buffers and you can just navigate to scalar type section. So you will see everything there. Also, you see these numbers. They are the unique field numbers used to identify a field within the message binary format. So there is a serialization while we are sending this data to server side. And you need to be careful about this. So it will be a binary format. And then it is something like hash map. I mean, in order to state username, I will say 1. In order to state password, I will say 2. So you will see it will be injected into the binary format by using these unique identifiers. And that fields are very important because when you define this for the first time, it is very hard to change it. So you need to be careful about this. And there is also a section within the protocol buffers about how to provide these unique numbers, how to reserve one of them, how to do the updates, etc. Let's say that if you want to see the whole example, here you see there is a create product request. This is just a proto file, by the way. In proto file, you see there is a message which is called create product request. I am saying that the field number, unique number, 2 is reserved. That means you cannot use it. And I am saying that the price, this time it is the field name, like username and password. So within this create product request, you cannot use the unique identifier 2. You cannot use the field name price. And then I am saying that required string title is equal to 1. So title is the field name and the 1 is the unique identifier. And also I am saying that this field is required. So you can see by required field, this is a required field. And also you see I just used 1 and then I have used 3 here because 2 is reserved and I cannot use it. Here, also, in order to state the slices, arrays, list, whatever you call within your language, repeated recommendation is 3. This time I am saying that there is a field here, which is type of recommendation, and it can be a slice, it can be a list, or it can be an array list in this case. So there can be multiple of them. And also there can be 0 record inside this. You see, there is enum definitions on line 8. I just define a color enum, and it may contain blue, red, and green. So, and then on line 14, I am saying that option color is equal to 4 and default red. So most probably this is very meaningful to you. You can easily understand that there is a field which is called color, and this color type is color, and then the unique identifier 4, and the default value of this one is red. So if you define enum here, you can just define your contract. I mean, the consumer will know that there can be 3 possible values here. If you provide, for example, black, most probably you will get a validation error on this side. You will get an exception. And we say a recommendation. This is just a custom message. And then you can see on line 17, it has product ID, product URL, title, image URL, and that's it. So very, I believe that I just wanted to explain a couple of advanced examples in this section. So service definition, let's say that I have a product service. At the end, when you define your gRPC service, the gRPC server, there can be multiple services inside it. So let's say that I have product service. Within this product service, you can use the create function. You see, in order to state the functions inside service, I am using a RPC term. I say create, and as you can see, it takes create product request as a parameter, and then it returns a create product response. So let's say that if there's an endpoint and there's you just wanted to do multiple operations. So you have server side, you have client side. You just wanted to do a streaming operation on the server side. What it can be, for example, you said that, could you please list me the products? And let's say that there is a pagination there, and then I just wanted to get all the products at the same time. I am sending the request, list the products, and then on the backend side, on the server side, it can stream the product informations onto the client side whenever it does a pagination. Let's say that it gets the first 10 result, just stream to the client side, another batch of 10 result, stream to the client side. You can do this one. So the streaming is handled on the client side, server side. Sorry for that. Client side streaming, let's say that you have, you are getting a couple of keywords from a resource. And then whenever you get a resource, you are passing this one to server function, and you are saying that get me the product, get me the product. You can do that. So here there is a message which is called products, and it can have a list of products inside it. And there is another message which is called product ID. On the client side, I am trying to do a stream operation, which is called get products in batch. As you can see, I am passing a stream of product IDs to this function, and it will return me the products from the server side. You can also do this one. The typical example on the real life scenario is, let's say that the clickstream data analysis. So you are getting continuously this kind of data, and there is a consumer for that. And this process sending this data within a stream format to the destination API, let's say that, I don't know, clickstream service or something like that, and it gets data from the server side whenever it gets a new click information from the user. Of course, you can do stream operation on the both sides, which is called bidirectional streaming. So you are sending keywords to the server side as a stream, and then it returns you the product in a stream format. So there is a live communication between client and server, and you are getting this data in real time. Okay, we talk about what is the message types, what is the service functions, etc. We define the proto file. So how can you generate this proto file data structure classes and services by using this proto file? Very easy. There is a proto compiler. You can install this one into your computer or your workstation machine or your CLI machine instance. Here I am saying that just generate the necessary classes by using the product proto file. What are the options? As you can see, I am providing options in terms of Go language, which is specific to Go language. Go output, I am saying that just generate the classes right in the current directory. And I am saying that the paths will be source relative. It will be relative to source of the proto file, and gRPC out and gRPC opt. So you basically generate the message, the classes, let's say that the simple POJO objects, and also you generate the service functions, which is needed by the gRPC itself. And let's say that you generate all the data and you need to implement client and server side by referring these classes. So when you generate these classes, actually it will not be your actual implementation. So what you can do is you can just implement a business logic on your server side and business logic on your client side, but you can use the auto-generated classes in order to send messages, receive messages, and of course use these response and request objects all the time. I will switch to a demo right now, and we will implement a GitHub-like application. Let me try to open my IDE. So let's say that I believe that my terminal is visible. If anybody can write something, it will be best. So here, I created a folder, gRPC in action, and this Golang application will be a simple Golang application that using the Go module. But let me open my preferred IDE here. I am using Golang for Golang projects, and you can use Visual Studio Code or Vim or whatever IDE you just prefer. Here, just okay. Switch. No. Switch. Okay. So here, I'm about to define a proto message file. So the main idea of this application will be I will send a request for the GitHub. I will say that get me the information of this repository, and then this server will return me that repository information by using GitHub APIs. So my main message will be repository on this case. Here I will generate a folder which is called repository, and I will define my proto file under this one. Let's say that file repository.proto. Okay, so what is next? On the next step, right for the first line, you will define your syntax. Okay, so like in the Python versions, you need to be very careful about this version in the proto file. So I am saying that I will use proto 3 in this version. And we will generate some kind of classes, right? You can define your package name within your proto file. I think there is a message. Let me check it. Okay, yeah. Let me enter to presentation mode. View appearance. So better now? Mhm. Okay. So it increases the editor font. I think in presentation mode it is it, but I will do something like this. So increase font size. I don't have a so maybe in presentation mode it is not doing it. What about like this? Okay, so I will do this manual stuff. Okay, so option go package. So I am saying that after this generation, what will be the package name on this case? Because you know in Golang the package name is important. github.com, my GitHub handler here in this case, and this will be gRPC in action. So this will be my package definition. And here I am also saying that this will be package repository. Okay. I can start my service definition here. This service name will be repository because I will try to return all the repository information, maybe a search. In this case, my function is search, and in this search, I will get stream data of search code request, and the return definition will be stream of, again, stream of. Let's say that search search code response. And here you just say that this is just a function definition. Now you see I have missing information on the message part. Now I can define my message definition. So the first one will be message, the search code request, and the main definition for this one, there will be a keyword. I will need keyword on this case, keyword. The unique identifier will be 1, and the another one is user, to define what is the original author of this one. So you may say that, oh, why I need a user on this case? Because I will use the public API of GitHub, and in their documentation they are saying that you need to provide the author in order to do unauthenticated API call. Here there will be a code response, and let's say that I only fetch the name information of this repository. So this is it. This is my definition of this is the definition of how I am constructing the contract of this gRPC. So what should I do next? I can just generate so you see I am saying say okay, so you see I am saying that this will be a relative, but let me, this will be a relative definition, and my proto file located inside repository.proto. So when you execute this one, option go package, why it is wrong? Okay, so here okay, now because the package name is this one, right? Because this is the root of the project, and the package name will be repository, and also I'm stating this one in this section package. When you have a look at this definition, I don't know if you can see the left-hand side, but here the files are generated. When you open it, you will see some ugly definitions inside it, and you will also see some gRPC definitions. You don't need to memorize everything here, but let's try to analyze what's going on here. So we said that this will be a modular application, and within my project root, I am saying that go mode, let's say that init, and you need to provide your again GitHub project path gRPC in action. Okay, it says that it is generated, but you need to do a go mod tidy, something like npm install, but the more extended one. I mean, it is also trying to analyze the imports and then maybe remove them if it is not needed, etc., etc. So let us wait for this index operation to be finished, and then we will start to implement server side first, and then client implementation. Okay. So in order to start your application, you can, so here I'm saying that in the directory, I will create a server package, let's say that, and I will create a client package. And in the server side, what I will do is I will create a Go file, which is called server. And in order to make this file executable, what we can do is we can just create a main function, right? Very basic main function. Here I am saying that main, so it is ready to be executed in this part. But let me open this one as main, because otherwise it will not be an executable file on our case. So within a typical application, what is the dynamic value on this server side? So it can be the port, right? Very first one. So let's say that I am about to pass some kind of value to this application, and it can be a program argument. In Golang, you can use this flag. There's a package which is called flag. Here, let me show you how we can do that. So first of all, you see name, value, and the usage. So name will be port, and the default value, what can be the default value? Let's say that's 10,000, and let's say that's server port. So whoever checks your application, they will see, oh, this application needs a port value, and you can modify it. So in order to make this flag work, you can just do flag.parse. Otherwise, you will see this application will not be able to see your port value that you pass to the application. And here, the first thing you need to do within the server function, just create a listener and then create a gRPC server out of it. Here, you can say very generic package net.listen. Within this listen, you can provide your protocol. In our case, it is TCP. And within the TCP, you can define what is the what will be the listener address. Let me do this. Printf localhost, and this port value will be something integer, and I am saying that port. Okay, when you do that, you may get some kind of error. You need to handle that. I am saying that let's say that it can be listen, it can be error. So we need to handle error on this part, but instead of having a generic error here, let me make it listen error. So you see there is a information here. You can easily say option enter in order to, no, not the rename. Okay. If listen error here is not equal to error, it's not null, sorry for that, then you need to return this one to customer, right? In our case, it can be log.fatal and what can it be? Failed to listen. Failed to listen. And you can maybe provide what is the error reason on this case, and you can pass this one to listen error. And okay, we will use listen, but after a couple of stuff. Here, we are about to create a gRPC server serve function. We will pass this net listen output to this gRPC server. But first of all, let's define our options for gRPC. Of course, they are slice and gRPC dot server option. Here, we will define a couple of server option, and gRPC dot, what can it be? gRPC new server. You see, I will pass my options here, but it can be a variadic parameter. So here it can be one or multiple parameters. So this will be an instance of gRPC. Let me try to extend it to a variable. In this case, it will be g. Okay, and after this part, we will say we need to. So we just created a service, but we need to register it, right? What is there here? Okay, unused variable. So here, what is our service? Repository service, right? Here, when you say that repository, you see there is a package repository because it is generated out of our proto file. And I am saying that register repository server, right? Here you will pass your gRPC server, and then you will pass the if you want, you can pass a couple of parameters more. Let's say that I have a new repository server. So we will come up here later, but as a final step, we need to listen the request. So gRPC server dot serve, and we are passing the listen here. Of course, you can just handle the error here. Let's have a look at that also. Listen, not listener, but this time it will be let's say that serve error. And here I will say that if serve error is not equal to nil, then I will say log.fatal and failed to serve, and pass your parameter, which is serve error. Okay, what about this one? So most probably when you define your server, you need to think a couple of stuff. So this is a server, and this server may depend on another stuff. So in our case, it will be a GitHub client. So what is GitHub client? There's a package which is called Go GitHub. Let me try to include this one in our repository. Yes, this one. Okay. This is a Go client for the GitHub REST APIs, and I will try to, right now, I will try to inject a couple of parameters here. So let's say that I have a struct that defines my server information. Type repository server. Okay, this will be a struct. Inside the struct, so let me add my first dependency, which is GitHub client. On my case, it will be the reference to GitHub.client. So my server needs a GitHub client. So we need to verify it. Here, I will use some kind of constructor here. Let's say that new repository service, which is I have already used in my server injection part. It will return a repository server, and then what will be the parameters? Keep in mind that this will be a reference, and it will return repository server, and you need to define only this part, and GitHub dot new client. So if you pass nil, it will use an unauthenticated request to your to the GitHub REST endpoints. So I create the repository service struct. I know how to generate it out of a specific constructor. I just inject the GitHub client into this one. Okay. Now what it says there should be a search function. Let's do that. So you can just do Alt Enter in order to implement missing methods here. You see, it just introduced me a search server. You need to implement that. But there's another one here. So instead of using this one, let me remove this part. Okay. You see, it will still complain about this must embed. But instead of doing that, I will do another stuff, which is very easy here, which is called, again, it is coming from my proto file class definitions. So unimplemented repository service. Instead of trying to define an empty or dummy function, you can just add this dependency to your struct definition. So we need to implement this part, right? So what it will be? We said that it will be a streaming operation, right? So is it there, all the parameters? Yeah, they are already there. So we are saying that this will be a streaming operation. So how? We can do this like this. Let me change it. So in the streaming operations, you need to have a for. This is an infinite for loop. In our case, there will be a stream, right? Stream dot. Where is stream? On our case, it is the stream of this one. Stream. Okay. So keep in mind that the client request already in stream format. And it will be a receive. So continuously, I am trying to receive value from the client side. And let me extract this one to a variable, and it will be something like this in, and the second value can be an error, no worries. So after this, of course, you need to handle this part, which is very important. It can be the end of a stream, etc. This kind of errors. So if is error equal to, there is a special enum for this. There's one. If this is it, you can say that return nil. Okay. What else? If error is, so if it is a of a, we are saying that return nil. If otherwise, if it is, the error is not equal to nil, then you need to do something else. Again, we are saying that return error. So this is the error definition until this part. And then we will do a GitHub REST API call. Let's say that my initial page is 1, and my last page is false. So let's say that I'm trying to do a pagination, and in order to say that my pages are finished, I am using a variable, and also page will be my the index for the page. So if it is not the last page here, oh, the typo, last page. So if it is not the last page, I will continuously search GitHub client. Okay. So in order to do a search, it is very easy. So in our, here there is a receiver function, which is R here. Within the R, we will access GitHub client, and there is a function in the GitHub client, search. Very easy. Code. You can just pass the context value here, context background, and here you need to provide your query, and query comes from the request, right? Which is called query and the user. So here you need to pass that you need to pass something like this. Q is equal to something. Q is coming from what is our stream, that keyword here, because keep in mind that here the stream information, I am continuously receiving value from the stream, and the value actual data is in the object, and I am getting value from the in object, and the field name is the keyword. And after that, I will do something like this. Just provide a space, and this time it will be user. Keep in mind that you need to provide user information, and this time it will be user. So this is my query operation, and there will be an ops. It requires an options object. So let's define it here. Ops is equal to, it comes from the GitHub client, by the way. You can say that search options. So you can say fill all fields if it will be easy for you. And let's say that I just wanted to sort by forks. Maybe I am trying to get, and then I just wanted to make it return the newest one first. And text match, I don't want to make this one. And in the list options, I will say page and per page. Here, you need to provide page, which is my page, and per page. Per page, let's say that 10. Okay. So what else? I just make a request to GitHub APIs, and I need to get this value as soon as possible. Here, okay, I will assign this one as, let's say that search response. And here, I don't care about this part because it is about HTTP response, etc. And I don't need it. Here, just remove it. But I may need the error information here. Search error. Okay. So after this, just do your typical search error check. If it is not equal to nil, then you can say return search error. And of course, you need to check the code results also. For example, if the len of search response dot code result is equal to 0, then you can do something else. For example, last page is equal to true, right? You are saying that I am reached and the end of the pagination. Here, the page will be incremented by 1. Here, what else? And I am ready to stream all the code information to the client side. So this will be a typical for range operation. So for this is your index information, and this is the code result. And what you will do is you will do a range on top of search response dot code results. And here in code results, so this is a very good usage in Golang. You will see if you have a look at the open source projects, etc. I am trying to send the message to the client side in a stream format, and think about our message format. I am sending only the name field, which is called code result dot name. And what else here? So it is trying to send message, but if there's an error, it will be equal to this one. But you can manage it. If error is not equal to nil here, we can just say that return error. So probably this will be okay. So that's it. So we just implemented the streaming part on the server side. Let's quickly write a client part. So it will be less time consuming when you compare to the server side. And it will be better if you remind me the remaining time, by the way. It was something like 25, but I don't know if it will be the same or not. Go file. Here, let's say that client. Okay. And I will do this one with main. I am saying main because you cannot use same package in different, so you cannot use, so that they are in different folders, because you cannot have save package. Let's say that I'm using main here. You cannot execute client and server if I put them inside the same folder. So that's why I'm separating those into different folders. So this time here, there will be a server address, because this will be my connection point to the gRPC server. I am saying that this time it will be a string, and just provide your server address. What will be the value? Let's say the default value is local host and 10,000, and gRPC server address. So we do this, and after that, main, do not forget to do flag.parse. So now we are ready to do our client connection. First of all, in order to connect to the gRPC server, you can still use gRPC, and this time we will use dial. So within the dial, you need to pass your server address. In server address, you see there they reflect string return the address, so you need to provide this wildcard here. And again, you need to pass the option informations here. But what is these options? Let's define them. Var options. This time, again, this time it will be dial option, not gRPC server option. Dial option. So what are they? What are they? Let's say that it will be equal to, and I will provide two parameters here, two options here. The first one will be with insecure, and the second one will be gRPC. Let's say that with block. Okay, and then we pass these parameters to here. Let's try to just extract this one to outside. In my case, it will be connection, and this will be error. And if you want, you can handle it. If error is not equal to nil, you can say that just throw a fatal error, fatality, and we can say failed to dial. Provide your message. Error. What else? After this connection, you can say that defer connection dot close. So here you see, if there's an error, if there's a function quit or something like that, you can just say that just close the connection before quitting this function. So we have a connection methodology right now. We need to pass this connection object to our actual client. So what is our client? Repository dot new repository client. That's it. So just pass your connection information here. If you want, you can just assign this to a variable. Okay. So this is my client. After this point, I can use this client object in order to make any kind of connect operation. So client dot search. You see the search function is ready here because it is already generated here. And for this part, the client connection, it will be better to use a context. So let me try to explain you what is the context here. So I'm trying to define a context with timeout, and this context will be derived from context.background, and the timeout value will be, let's say that 10 seconds, time.seconds. Okay, and after that, you can assign this one to a value again, and this value will be context. Let's say that context, and this will be canceled. Okay, so here again I will do defer cancel, because if there's a problem, for example, timeout reached, then it will call the cancel function. Okay, even it is not reached, the cancel will be called after you are quitting this function. Here you need to say that context, we are about to reach to the end. Here I am saying the stream, and we are doing a stream, right? If you are doing a stream, I can do this. This will be stream, and the second one will be stream error, of course. Stream error. And if there is an error, stream error is not equal to nil, I can say that log.fatality, let's say that failed to stream. And you can provide your message here, stream error. Otherwise, you need to print your if you are not able to stream, you cannot do anything. So you are trying to stream, but you will do stream get in another function. So let me try to explain it to you here. I have already read a snippet for this. So you see there is a separate Go routine here. I am continuously streaming messages coming from the server side. I am trying to get that. If there is an error, I am closing done. I will tell you this one. If I cannot get the receive data from the server side, I am throwing an error. Otherwise, I am printing the name of the repository. But what about the client search side? And that part will be this one. So here, let's say that I have keywords. Keywords means list of search keys. Let's say that on my end it will be string. First one, let's say that raft. The second one will be, for example, spring, and maybe it can be GDG, and it can be, let's say that Angular. Okay, and here there is a channel which I already defined below, and this is a channel of type Boolean. You don't need to care about this part because it can be a bit complex to you, especially the channel part. But here, okay, on this part. So I am trying to get these values, okay, and then I am for each keywords I am trying to do a search code request, and the user is this one. The keyword is fetched from here, and I am sending this one as a stream to the server side. If I have an error, then I will say that failed to send here. And now we can just use this function. Let me try to execute both of them. Okay, so here, since this is the streaming operation, for sending requests, there is a Go routine. For receiving data, there is another Go routine. And there is third Go routine that handles this stream operation. So if it is done, then we are saying an error. If there is a done, there is an error here. Of course, sorry for that. If streaming is completed, we are checking if there is an error inside it. If there is an error, we are printing the error here. If there is nothing, we are just saying that it is done. And we say streaming finished. Let me run this function first. This one. Where are you, main function? This one. Oh. Okay. Sorry for that. What is the port? Okay. So here it should be address of that. Okay, the GCP server is running here, and let me try to run this one also. This is the client application. You see, it continues to stream data from here, and then get data and try to print everything here. I search for Angular, for example. You see Angular CLR JSON. This is the exact same stuff when you do something like this. GitHub. You see, you go here, and when you try to search something, for example, Node.js, when you do that, you see there is some results, right? that is the one. You see the code here. It has file name here. We just printed the file name of this section, and that's it. So the demo also is over. If you have any kind of question and if there's a time, I can happily answer them. But other than that, thank you all for listening this presentation. Sorry, I don't hear you. Sorry for that. So in this example, it is not necessarily a version 3, by the way, and version 2. I just wanted to say a couple of examples, mixed examples. But in version 3, you don't need to use required, for example, but you can still use optional, because by default it is required as far as I remember. And when you use required, most probably it will throw an error. I can also check it. But there is no version restriction in this slide. I just wanted to show some combined examples. Okay, let me do required here. Sick. See, in syntax 3, required fields are not supported in proto 3. So here, the message, the version is not 3. So I just wanted to show the combined examples. But in all of the demo project, I have used syntax 3. That's true. Okay, let me show you that example. If the files are too generic, what I do in that case, I can just show you a live example. Here, let me go to the one of repository. Here, repositories. And if it is too generic, I'm creating a separate project, something like this. And there is a GitHub workflows here. My proto files are located inside the proto here, right? Whenever I merge something into main branch, it just triggers a GitHub action. And based on your configuration, it just generates data structure classes and service classes. They all have a path. So I directly use this dependency within my projects. But let's say that your application data structure classes is very tightly coupled with the service. Let's say that the payment service, and then they have payment request or something like that. At that time, the proto files are located in the payment service, and in most of the time, I'm using monorepo for microservices also, and the proto files also easily can be reachable from the source code. I'm not a fan of creating a separate repositories for all of the microservices. But if there is something generic that can be used within the microservice or can be consumed by some third party, etc., at that time, I am using a different repository for only proto purposes, and it also has a GitHub action to generate files. I don't know if, yeah, for example, this one, it just generates everything for your purpose. Yeah. Make sense?